Welcome to Statics Lectures by Civil Thinking, and today we are going to solve another problem on resultant of force systems. Now before I move on, I suggest you to please watch the video lectures in sequence one by one as in the playlist so that you understand better. Now the playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the problem. Three columns are erected on a footing which exert load P1, P2, P3 being 10 kN, 30 kN and 20 kN respectively as shown in figure 1.4b. Okay, this is figure 1.4b. Okay, the coordinates of the column loads are also given in the figure. The coordinates of the resultant column load will be. Now let me tell you what the question is all about. Now you can see this is a square footing. Okay, this is a footing, and on the footing there are columns. Okay, at this point there is a column, there is also a column at this point, and there is also a column at this point. Okay, now P1 is the load of this column, P2 is the load of this column, P3 is the load of the column which is here, right? Now this is the coordinate system. This point has the coordinate of 0 0, that is, it is the origin of the coordinate system. This is the x-axis, this is the y-axis, right? Now we have to find the resultant of them and also the coordinates of the resultant, right? Now how we are going to find the coordinates? First of all, we need to find the value of resultant. Okay, now all the forces are vertical, right? This P3, P2 and P1, they are vertical. These three forces, they are vertical and they are parallel to each other. Now this is a parallel force system. Okay, and since they are all parallel and vertical, now let us say R is the resultant. Then the resultant is the summation of all the forces in vertical. Okay, V for vertical. Now so resultant is P1 plus P2 plus P3. Now we are provided with the value of P1, P2, P3 here. 10 plus 30 plus 20. Okay, this is P1, this 30 is P2 and 20 is P3. So P1 plus P2 plus P3, right? P1 plus P2 plus P3 is what? 10 plus 30 plus 20, right? Now 30 plus 20 is 50, 50 plus 10 is 60 kilonewton. So the magnitude of resultant is 60 kilonewton here. Okay, now we have to find the coordinates of the resultant of column loads. Now we have to find the coordinates of this resultant. Now let's assume the resultant is somewhere here. We don't know right now. Let's assume this is the resultant. Let me change the colors. Now let's assume the resultant is at a distance of y bar from x. Okay, it is at a distance of y bar normally from x-axis. Okay, this is the x-axis. As you can see here, this is x-axis. Okay, it is at a distance of y bar from x-axis. Okay, and now let's assume it is at a distance, normal distance of x bar from y-axis. You can see this is the y-axis, right? This is the y-axis. Excuse my handwriting. Now we have to find the coordinates of the resultant. It means we have to find the value of x bar and y bar. Okay, now let's apply the varignon's theorem on x-axis and y-axis. Okay, now according to varignon's theorem, moment of resultant, okay, resultant about a point, or you can also say about an axis, okay, or a line, or about a point, is equal to moment of forces about that point or about that line. Okay, about that line. Okay, this is varignon's theorem. I have already made a video lecture on varignon's theorem. If you want to watch the video lecture, you can click on the pop-up on your screen. Now varignon's theorem is really very easy. I will explain it here. Now this is the resultant. We will find the moment of this resultant about y-axis. Okay, now moment of resultant according to varignon's theorem, moment of resultant about y-axis is equal to moment of all these forces about y-axis. Okay, similarly moment of this resultant about x-axis is equal to moment of all these forces about x-axis. Okay, we have to apply Varignon's theorem two times, first on the y-axis, which will give us the value of x bar. Then we will apply the Varignon's theorem on x-axis, which will give us the value of y bar. So let's first apply Varignon's theorem on y-axis. Okay, y-axis. Now, moment of resultant about y-axis is what? How far is resultant normally from y-axis? It is x bar, right? So moment is resultant multiplied by x bar, and resultant is 60 kilonewton, right? It is 60 kilonewton. So moment of resultant about y bar is, y-axis is 60 multiplied by x bar. Okay, let us assume this resultant is an exerting a clockwise movement. Okay, and clockwise movement is positive. I am assuming the resultant is exerting a clockwise movement when you look from here. Okay, it doesn't matter anyways. This is the moment of the resultant, right? 60 multiplied by x. Now it is equal to, according to Varignon's theorem, moment of p3 about y-axis plus moment of p2 about y-axis plus moment of p1 about y-axis, right? That's Varignon's theorem. So let's first find moment of p1. Okay, now p1 is how much? 10 kilonewton. I'm assuming all of them are an exerting clockwise movement, so all of them are positive. So p1 is 10 multiplied by, right, p1 is 10. Now how far is p1 from y-axis? Normally it is at a distance of 8, right? Because x coordinate is 8, so it is at a distance of 8 from y-axis. So 10 multiplied by 8 plus, now let's find the moment of p2. Now p2 is 30. 30 multiplied by, how far is p2 normally from y-axis? It is 6 plus moment of p3 about y-axis. P3 is how much? 20 kilonewton. 20 multiplied by, how far is p3 from y-axis? It is 1, right? 1. Okay, so that is the Varignon's theorem. So 60 x bar is equal to, let me use a calculator to calculate this. 10 multiplied by 8 plus 30 multiplied by 6 plus 20 multiplied by 1, right? It is 280. 280. Okay, so x bar is what? 280 divided by 60, right? Let me use a calculator. 280 divided by 60, it is 4.66. Okay, 4.66666. So I will approximately take it to be 4.67. Okay, so we get the value of x bar to be 4.67. I will write here. Now let's find the moment of resultant and forces about x-axis. Okay, so first let me erase all of this. Let's find the moment about x-axis. Now according to Varignon's theorem, moment of resultant about x-axis is equal to moment of all these forces about x-axis. Okay, so let's first find the moment of resultant. Now resultant is 60 kilonewton. How far is 60? How far is resultant normally from x-axis? It is y, right? So moment is r multiplied by y, and r is 60, right? So it is 60 multiplied by y bar, right? This is the moment of resultant. Now let's find the moment of p1. Now p1 is 10 kilonewton, so it is 10 multiplied by, how far is p1 from the x-axis? It is at a distance of 2, right? Because the y coordinate will tell us the normal distance from x-axis, and the x coordinate tells us the normal distance from y-axis. Right now we are finding the distance of p1 from x-axis, right? X-axis, so we will use the y coordinate. Y coordinate is the second coordinate, right? 8 is x, x coordinate, 2 is y coordinate. So y coordinate is 2, so the distance of p1 from x-axis is 2, right? Plus, now let's assume all of these forces, they are exerting clockwise movement. Okay, basically if we look from here, they are exerting anti-clockwise movement, but all of them are exerting anti-clockwise movement. Okay, so they will cancel out. We can just write positive values, it doesn't matter. Now p2 is 30. How far is p2 from x-axis? It is 6. plus, now P3 is 20, right? 20 multiplied by, how far is P3 normally from x-axis? It is 8, right? Multiplied by 8. So 60 y bar is equal to, let me use a calculator to calculate this. 10 multiplied by 2 plus 30 multiplied by 6 plus 20 multiplied by 8. It is 360. So from here I will get the value of y bar to be 360 divided by 60. And how much is it? 360 divided by 60, right? So it is 6. So y bar is 6. Okay, so x bar, y bar is how much? 4.67, 4.67 comma 6, right? So which one is the correct option? It's very clear, the option C is the correct option. Okay, so this is how we solve this problem, and if you have any doubts, please comment. I will definitely help you, and see you in the next class. Thank you.